I'm going to be talking to Lynne Mueller, who is the CEO of BC-based Sharc International Systems, and that's Sharc with a C, not a K. And they have a system that extracts thermal energy from wastewater, and seems like a lot of opportunity these days as particularly big cities try to get off natural gas in new construction. So welcome to the interview, Lynne.
Well, thank you so much. It's an honor to be here.
I'm glad to have you. Now, look, let's start off with just a brief overview of how your system works, please.
Yeah. So what we do, our whole purpose in life is to recover that hot water energy that you throw away every day when you shower, do your dishes and laundry. So I spent a fairly long career in the geothermal heat pump business. And this is just an extension really of geothermal. Instead of the ground, we use the sewer. And started in my own home when I found out that my hot water bill was about $1,200 a year. And I thought, why can't I get that back?
Okay, so you can imagine how anybody watching this is going to go, where does he put his equipment in the sewer line?
Yeah, well, that's the thing we had to learn. When I first thought of it, I thought, gee, this is going to be easy. And then we found out we didn't know a darn thing about sewage, and we had to figure out how to get that. And what most people don't realize, just the sheer volume of flow there is every day in a city. And Vancouver, for instance, probably has about 600 million gallons a day of sewage water. And it's all been heated about 20 degrees C just by people throwing away their hot water. So what we had to invent was the method to clean the water so you could put it through a heat pump. And took us a while. And we're kind of now a 12-year overnight success, but there was some pretty hard slugging there for a while. But we are undoubtedly the best system in the world for what we do.
So does your system go in the sewage system, sewage lines, prior to, say, a water treatment plant?
Yeah, that was what I wanted to do. Is when I started, I wanted to put this in every building in the world. So I built the Sharc system, and Sharc happens to stand for sewage heat recovery. It's not, not named after the fish. So, but then we learned, that there's just an artery of pipes full of this warm water, and we could put the systems anywhere. So ours are completely sealed, and they're pretty much indestructible. So you never have to smell it, and you're not pumping a lot of sewage water around through buildings and stuff. So it's accessible. You wouldn't believe the series of pipes there is around the city. And so much flow in them. So
would your system be installed at the building level?
It can be. We have two different products. We have what's called a Piranha, and it's made just to do one building. And now we do them down to even like 20 apartments. And then we have the Sharc, which is a bigger one that we have, for instance, in False Creek, where they recover enough heat from the sewage leaving downtown Vancouver to heat 22 million square feet of apartments.
Wow. So the sewage is at 20 C. Do I understand that correctly?
Roughly year round, around 20 C.
And how much heat do you extract from the water? Do you take the water down to 18 C, 15 C? How does that work?
Well, that's the really funny part is we've got that system running in Vancouver, for instance, and after taking out enough heat to heat 22 million square feet of apartments, you still can't detect a temperature difference in the flow. There's so much energy thrown away every day.
Well, now that's interesting. Does your system also, in addition to providing heat, does it also can it be used to generate electricity?
Not electricity, because what makes us efficient is just recovering the heat. We're 400% efficient. If we tried to use that heat to produce electricity, it's only about 10% efficient. So you would lose efficiency. But because we don't convert it to anything, and we heat hot water and we heat buildings, it's unbelievably efficient.
Now, let's say that that you're working in an existing development. You've got existing building stock. Does that, and in BC, for instance, that means that it could be forced air, or it could be hot water, or it could be electrical. So how do you, if if it's not, doesn't already have an existing boiler and existing pipes and radiators in the building, can you still convert it to your system?
Um, Sometimes you can't. Like there's just some of those old buildings that are, have all those old cast iron radiators and stuff. You just can't. But most of them we can. And quite normally it's I wouldn't want to say it's easy on everyone, but it's doable. And change, to make things change, you have to do things different. So it's become 12 years ago nobody had heard of it. Now we're really mentioned with solar and wind and the other technologies. And the great thing about sewage is the flow is exactly the same at every day of the year. Like people just do the same thing every day.
Well, one of the reasons why I find this really fascinating is because reducing natural gas use in the existing building stock is one of the biggest challenges that any country's got. And it sounds like your technology, I mean, you don't have to generate new electricity, to run heat pumps and so on. The heat's there already and is a waste product. So it seems like there's lots of potential for this. How many have you got, and can this business be scaled up so that you're doing thousands, tens of thousands of units?
Yeah, we're kind of facing that right now. Is that we did a lot of pilot projects and tested this and that. Well, we're a proven technology, so now it's full on implementation. And we just completed and commissioned a system in Denver, for instance, that excuse me, Denver, that serves 250 acres of new development where the stockyards used to be. So there's a university, there's a hospital, and there's all kinds of residential. But there it does heating and air conditioning, because the sewer line's about 20 degrees C. So if you need to get rid of air conditioning heat, you can also put that in the sewer line. So it becomes very, very vital now, because as you probably noticed, the world is warming up a bit, and air conditioning in Vancouver is a larger load now than heating. And so when you look at that, we can take the waste heat from the air conditioner and put it into the hot water as well. So we've, when I started, my mantra was that, buildings are built so much better, the glass is better, the envelope, but there's still a 6-inch hole in the floor where 50% of the energy goes out and you don't do anything about it. So.
Well, that makes a lot of sense to me. Now, so let's talk about new building stock. And Washington State just passed a legislation that will require, I guess, I don't know if it bans natural gas, but you have to basically electrify or come up with some other technology to heat and cool new buildings. And do you see this as a big opportunity, since other jurisdictions, Vancouver, other big cities, appear to be following that trend?
Well, I sure hope so. But yeah, I really do. And you look at Seattle, they've mandated no gas. But you go to some other cities like Boston and New York, they don't tell you can't use gas, but they put penalties on usage that are so high you have to find an alternative. So by 2030, New York City has to retrofit 900,000 buildings. And I dare say that we'll be in a lot of those. And we've worked closely with the utilities there. It's Con Edison, Consolidated Edison, and National Grid is the gas supplier. So they've capped National Grid's gas supply. They can't supply anymore, and they have to start reducing. So we're actively working on about 20 different projects in New York City. And I was just down in Washington, D.C. on Thursday and Friday. And we have done a building there for DC Water. That's the greenest building in North America. It's won all kinds of awards. We had an open house there. We were expecting 20 engineers and 150 showed up. So I think we're on to something.
Well, if you can get engineers out, you're doing well. Final question, Lynne. I'm interested in the economics of this. How is it? Is it competitive with existing heating and cooling systems?
It is, and we could stand alone without subsidies and stuff. So the worst payback we've seen is about 7 years. But with Clean BC and all of this, they'll pay for sort of half of the installation. So the payback is usually 2 or 3 years. And now that you have to decide, um, you can't use gas, so you're going to use something. So you decide between us and air source or whatever. Well, we're clearly the life cycle winner in that one. So we did what was called the Electrical Power Research Institute's Incubate Energy Challenge. And that was done during COVID. And we did a test here in Vancouver. We proved that we have the most efficient means of making hot water in the world against any technology in any climate zone. So we're pretty convinced, Sharc has got a future. And the reason I do it is, I'm too old to worry about making money anymore. So I got 3 little grandkids that I want to see have the things that I had. I used to go up north to do refrigeration work, and now those villages are underwater. We've got to do something. So I like to get up every day and think I'm doing something good for the world.
Well, this sounds like terrific technology, Lynn, and congratulations to you and your the team in your company, and all the best in the coming years. Hope it's a smashing success.
Me too. And thanks so much for your time. It was a real pleasure to meet you.